in the picture. You know where the action is? At the interface, where the wave hits the particle. That's a chaos zone. That's where the waves and the particles interact, and there's an etching at the surface of the energy of the waves and the physical energy of the particle. And this is a chaos place. And it's the same whether the particles are big or small. The Earth is a particle. The waves of the solar system are the nonlinear waves. And the chaos is where? At the surface of the Earth. And the interesting part about that is what happens at the surface of the Earth. Well, think about this. Before there was life, what kind of chemistry did we have? Inorganic chemistry. Non-life. The kind of chemistry that seeks stability. A rock likes to be a rock. It doesn't want to change. It'll stay a rock for as long as it possibly can. But when pigments evolved, pigments were able to trap photons of light from the sun, the waves, and take that energy of the photon and use it to move electrons, and in the process take inorganic chemistry and create organic chemistry. Yeah, but we're made out of organic chemistry. So what does it say we're actually made out of? And the answer is this. We're made out of the Earth and the sun. We are both at the same time. We are energized Earth. An energized Earth does not want to sit still. Energized Earth is an active, moving, organic matrix. And so we are life, but we represent energy, half, matter, half, coming together. And so when we look at life, if we look at the Earth before there was any life here, photons would hit the Earth, be absorbed, and then the energy would radiate off as heat. But once that inorganic chemistry was endowed with the ability to express organic chemistry, it changed. But in this case, let's just watch what happens here. Organic chemistry is the one that seeks activity, okay? Now watch. The photons, oh, it's not going to happen. I'm sorry. It was an animation that didn't seem to play right now. What was the point? Photons of light came down, hit the Earth, and after the evolution of organic chemistry, the photons didn't necessarily radiate back away again. The photons were now trapped in a matrix of organic chemistry. So the sunlight is accumulating on the surface of the Earth. The Earth is energized at the surface. And the waves come from the sun and the solar system. The particles come from the Earth. And the chaos zone in the middle is where life occurs. So when we look at it, we can then relate and say, as is above, as is below. Then if we understand it this way, we physically came from the planet, but we energetically came from the sun. And in looking at that, then you could call the planet Mother Earth, because this is the physical origin of where we came from, and Father Sun are the waves. And then even in our own reproduction, the egg is the earth that we come from, and the sperm doesn't deliver any earth, it just delivers information. So the reality is, it's still the same fractal imagery, I don't care what level you want to look at. But then what we want to do is not run out of time. So I'll quickly show you how evolution, I say it how it occurred, is at first in the primeval seas, at first, all there were, oops, go back. At first there were just proteins floating around in a solution. That these proteins are just responding to the environment and moving all around. But the phospholipids are self-assembling structures. A membrane is a self-assembling process. You can shake them up and they create membranes automatically. The proteins that get trapped in the membrane are in a separate domain because of the lipid layer. If the environment changes on the outside, the environment's still stable on the inside. So life occurs within a membrane structure because those are regulatable domains. And so life needed the membrane first to start. But now I have proteins that can carry out a function inside the cell, and cells started to develop into communities. So the bacteria cell was not a single cell as we know it. They live in a community and interact with each other. But they start to come together in what is called a biofilm. And a biofilm represents a collection of bacteria that surround themselves with like a membranous structure. And that within that structure, the bacteria exchange information, even including DNA. And there are different bacteria, so that you can take a bacterial population, put it in a membrane, but if you do that at some point, then those bacteria in a membrane ultimately evolve into the more advanced cell called a eukaryotic cell, where the structures on the inside appear to have been formerly bacteria surrounded by a common membrane. Then you take that human cell, which is the fundamental unit that we're made out of. Cells started to come together in community. Take a grid, and wherever there's a grid square in here, put a single cell in, and whatever the grid is covering, make that cell do that function. So if a grid is over here, then the cell that ends up being this part will take care of respiration. If the grid's over here, a cell that becomes that part will take care of reproduction, etc. And what do you end up doing is you start creating the model of a human embryo, which is this structure, and guess what? It has the same layers as the single cell. The outer layer of the skin is called the ectoderm, which is the skin and brain of the human embryo. The inner membranous structures form the inner membranous structures in our gut, respiratory, digestive, excretory system. The pink stuff is the spaces in between, and they form the mesoderm. What's the point? We are made in the exact same image, repeated again and again, and we now are cells in a larger organism. Each one of us has a job to support the life of the whole organism, so we are like cells in a multicellular structure, repeating it. This then leads me to this wonderful conclusion. It says, yes, civilization is a living system comprised of us as cells. And since the nature of fractals is self-similarity, it would say that then as human civilization evolves, it will have self-similar characters to the evolution of animals. So you can look at the status of a civilization and see where it is on the scale of evolution. So we go back and say, look, just looking at the vertebrates, fish, amphibians, reptiles, birds, and mammals. So where are we? Well, first of all, the fish cultures were in human evolution was called mariculture. These were the first civilizations we now recognize were on the planet. They lived at the edge of all the continents. They traveled across the water, continent to continent. They had to live with the water. Water, if there was water, they could live wherever that water was. But the next evolution was amphibians. Amphibians were unique. They took the water with them to the land. They didn't have to depend on being in the water anymore. They could take water with them. So the reality is, the amphibian phase of human civilization was agriculture, where we no longer were restricted to the water at the periphery, but using viaducts and irrigation systems, move into the land and populate the land, as the amphibians did. After the agriculture period, or amphibian period, come reptiles. Well, reptiles, if you ever see like these little reptiles, they're like little digital organisms. They click their head, you know, their tongues flick, their eyes click, click like this. And you watch them and they're almost like machines. And in fact, dinosaurs are the fullest machine nature of a reptile. Here's why. A dinosaur and a lizard are exactly the same except scale. And when I was a kid, before animation in Jurassic Park, they made dinosaur movies like 100 million years BC or something, Victor Mature, God, that's a million years ago. And what did they have? They had dinosaurs, but what were dinosaurs? They took these little tiny lizard and glued some horns